So let's go back to our looping. And yeah, the book mentions, we're talking about while loops, that you can use EOF, end of file, or end of stream, right? So this approach is also workable, right? You are, again, with the provision, people are not entering garbage, right? You still, this is not very robust code because, of course, this is just an example code, because if people enter garbage, you'll still need the file. Yeah, I still like that that little loop I added in the code spaces, right? Right, this little helper function, right? This little here, right? Fail, clear, right? Again, you could maybe rewrite this maybe a little bit tighter, maybe less, right? But still, again, as long as you write it once, you can keep reusing this type of function. Now let's see if we get to for loops, right? And the file is stream end of file. You can check. That's one thing you can do, right? Yeah, you can add, of course, multiple statements. And we use in C++ just like C, right? We use double ampersand. Is that ampersand? Ampersand, right?
Yes.
Yeah, ampersand. Yeah. All right. So Fibonacci, right? We can check. We'll talk about analogy Fibonacci. Right, Fibonacci code, right? Yeah, I want nth Fibonacci number, right? So we could do basically a very simple program. I don't think I have given you one. I could write them quickly, right? Thanks to Copilot, right? You have two numbers, right? You need to start, and then you have a while loop until until you reach a correct number. You have a counter, basically, right? That's possible. But let's see if maybe if you have time, we'll do this. But I want to get for loop, right? Again, so in while loops, we saw ability to break out of the loops, right? I see sometimes people use there's the other loop. Let's do do while loops. Let's do a do while loop. Do while, right? So do while loop is similar. So how do I call this loop? I call this loop should first and ask questions later, basically, right? You don't care. In other words, the post condition should end. We guarantee at least one execution of the loop, right? So in practice, it's not often used, right? So let's see. We do have do while loop. We have do while loop. Looping. No, it's for looping. So some uses of do while loop. Yeah, you have to ask for the input, right? That's possible. Yes, possible. What else? Menu-driven programs, reading a file. Yeah, I guess you could read the database and so on. Okay, let's AI will get to. So let's start. Let's example. So include IO stream, of course. Do we want limits? Sure, why not, right? Yeah. Let's write the function to get an integer from user using do while loop. See how it compares, right? So again, get integer, right? So do, right? We are going to output a message no matter what. We're going to ask for number. Well, the thing is, could we do this? They say while fail, but the thing is, this looks like oh yeah, but this is this? I have a feeling this will run forever, no? Because if this doesn't look good to me, AI don't trust AI. Remember, trust but no, trust but verify, right? This looks very suspicious to me, right? Because this flag is fail, so this fail will not be fail anymore, right? I think we'll run this forever, right? So let's take a look. Ignore invalid output. Wait, let's see. And because it will stop, I think it will stop. Let's try this. Right? No, let's use this function domain. Yeah. Okay, I am not sure about this. Okay, where's my terminal? Will I get my terminal back? Oh yeah, there's terminal. Okay, yeah. So I'm not 100% sure about this. How should you say? I'm not 100% I agree with AI in this case. So G++, while, do while, yeah, undo while. Yeah. Oh wait. Sorry. Yeah. Okay, no errors. Okay. How big is it? Do while. Not very big. Same about roughly same size. Okay, we'll do this. Do while on enter integer. While this. You entered 0. You see what happened, right? Invalid input. Please try again. You entered 0. On program is not syntactically incorrect. However, it is semantically wrong because this part here, right? So could we make it somehow? Well, we could do. Let's see if we can tighten it up, right? So this part we want to leave this while it's failing, right? So what we could do, I don't know what's going to happen, right? Right. So we could sort of start with clearing, right? Let's do that. Yeah, we could do this, right? But again, you see, this is. I don't like this. This is why I don't like do while loop here. In general, I rarely use do while loops myself in practice. Usually, they don't make while loops. I think are clearer. It's rare that you need to do something without checking operand conditions. Very rare. You know, maybe any of you have some examples where it's good usage cases, right? So, for example, Python famously does not include do while loops, right? There's no such things, right? That's why also I'm a little bit biased, right? Most of my work these days is in Python, but again, in C++, classically, again, even then, when I wrote a lot of code, it's in C++ and C, but it is rarely used. Okay, so this, what I don't like, this part here, right? I rewrote the logic, so I do something. I don't really like this. So the first run, I am clearing flags even if they were not set. Okay, this will be interesting to see, right? Sort of, I need it like a tabula rasa, like a blank state, basically. So, before start, right? Okay, let's see if this works. I don't know. Let's try this one more time. Compiled, okay, do while. Okay, not worse. So what happened? Yeah, oh no, it works, but okay. It works, but what the problem is, message. There's no message. Please enter an integer. Why didn't this message not? If sale. Interesting. Well, but no. End line buffers. Yeah, right. I know what happened. This was the problem. Okay, let's try this one more time. See, that's the thing. That's why I don't like this approach, because you need to clear the buffer. So end line will flush the buffer. What does that mean? Flushing the buffer. Output is going to the buffer. Right? So, right now it should work correctly. But again, that's why I don't like this approach. Do while. RBS. Again, follow this. Okay, yeah, it's not like I said, it doesn't work quite well. So it works correctly, but the logistic not very good, right? Not very good example, right? So fix me. The do while is not quite correct yet, right? So we get we do not see messages and it is valid. Right, okay. So yeah, that's something maybe you see. If you can find a good use, I can tell people, oh, do while is great. I don't know, maybe some of you want to use it. So, do while example. But I want to go back to the for loop, of course, which is our main workhorse, right? Let's see, or for. So, philosophically, we do while loops now, to some extent do while if we don't know how long we want to work, right? But for loops, if you have 1,000 items, we don't really want a while loop. I mean, we could, but we don't. We want to use for loop, right? Because it's nice, compact, right? Famously, of course, the Golang language does not include a while loop whatsoever. It uses a for loop only, right? It's kind of like in between, right? For those who use Golang, right? They don't even like while loops completely. The guy who, the guys who worked at C. So, but this is a syntax I think you all know and all love to some extent. I don't know, love, maybe that's a strong word to say, but you don't hate it, right? You don't hate for loops, I hope. Right. So, added do while. By the way, I wonder why is now I can't source control is saying I don't have any new branches. What's up? Is that git pull? No, it's update. I can't push now. I don't know what's up. Is that okay? Let's do a new one. So for loop. That's right. So philosophically speaking, we use for loops when we know how many times we need to loop, right? That's the main thing, right? Yeah, okay. So, good IO stream, good limits, maybe. I don't know if we need them yet. Let's see what the book says. What kind of nice assignment we could use. Non-negative integers. What could we calculate? Let's calculate. This. Hello 5 times. Okay. What could we calculate? Let's do Fibonacci number, right? Let's do Fibonacci number. Let's calculate. Let's make a function to find nth Fibonacci number, right? Right? Yeah, Well, okay. Sometimes you start, is the question zero, is zero the Fibonacci number? I think 111 usually. Sometimes we start with 1. Yeah, okay. Right. It's another thing, of course, even such a simple problem, this one off by one error will be solved. Yeah. Yeah. So 0 is 0. Okay, right? So, int get Fibonacci int n, right? Now, let's do the for loop, right? For, but I think this is going to use a while loop, right? No, it's using n loop. Okay, very good. Okay, so we need some initialization. A and B is 0 and 1. Declare a variable to store the current one, C, right? And we will loop n times. So, current, right? So we need A, B, B, C. Is this great code? Because A, B, C is too generic. I really don't like it. I don't say it's amazing because, of course, the naming could be better, right? Of course. Naming could have been better than A, C, but but for small functions this is acceptable, but not perfect. Yeah. Okay. Right. Because ABC. Right. So how is this going to work? Well, the beauty is, of course. So we enter and we say 0. Right. If we say 0. Is 0, so how is for loop going to look here? If somebody enters 0, A is 0, right? That's a current, right? Next. So I would probably rename it current, next, right? On the next one, right? So C, A equals B, A is next, right? Current. So it looks correct. Let's try it. All right, let's test it. Now, of course, and now let's write a map to this function. We will use a loop to get first main, right? Right. On we will loop 10 times. Right. Okay, looks okay, right? For loop. So, what's the complexity of this type of code? Again, algorithms. This main. What do you think? Is it? This is n, right?
Can you show the get Fibonacci?
No, yeah, let's get Fibonacci.
N squared.
N squared, of course, right? Because the loop is hidden inside the function, right? Because again, if you don't know what this does, this depends. If this was like if this was n cubed, then the complexity would be n to the fourth, of course, right? And so on and so on and so on. If this was like n log for some reason, right? Of course, there are tricks to get Fibonacci numbers, right? So it will also be okay. Standard. Okay, by the way, this is using standard out result. It didn't use using namespace, so I have to keep putting std, right? Std, 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 std. All right. Note. So in this version, we are not using namespace. So we have to keep using. Okay. All right. It looks okay. Program looks okay. Fibonacci looks okay. Let's run it. Let's compile G++. Here we go. Let's get some errors. I want to get some errors. For loop. What should I call it? Output feed. No errors. What's up with that? Some errors. Okay. Thanks for playing. All right. Kind of mean, but okay. So first, second, looks okay to me. Again. If I see this type of program, of course, I would like to have it add some flags, right? Let's add some flags. Let's add flags. Let's not 10 Fibonacci, but let's get and print the first and we'll get the number from arguments. Okay, right? Also, we will use default 10. Okay, so what we'll do is default int default n is 10, right? We of course want what? Int argc, arg vector, char arg vector. We'll talk about these in a few lectures, right? This is basically an array of C-type strings, right? And then we'll solve, okay? If, yeah, all right. We assume, big assumption. We assume okay, not too hard, right? Sparse, fine. First, I need to put this here. Okay, now that's it. And of course, this is wrong, so we need n, right? Okay. And again, I think you all know about this. So the one thing about this, of course, is that I has local scope, right? I should not be here, right? It's used for local scoping, right? That's a good usage. Some language don't have local scoping, right? You want I is locally scoped. Yeah. Not all, not true. Yeah, not okay. Now, otherwise, the program is very simple. Now we can compile. Hopefully, get some errors. No errors yet. So fib still works fine, but now, of course, the advantage is I can put 100, right? See, it'll work. Works. Wow. There's only a slight problem. Remember, the Fibonacci problem. What's happening? Why am I getting this garbage? Oh, too big, right? I'm getting overflow. So, again, a quick and dirty solution be long. Can I do long? Let's try this. Let's try. So, right, A and B. Well, you see, I have to make generic typing, right? So, double precision, no, but long in. Right. So this is still not going to be great. So long in. I need to represent long in, and again, this doesn't. This only goes up to 16 bits. I mean, 64 bits. Right. Right. Of course, if you think about it, right? Of course, in this particular case, this also leads. Is this sufficient use? Of course, no, because if you're going to print them, I could, of course, have made this linear, right? Right. So if you think about it, yeah. How we could have gotten, made this function more optimal, right? What is the complexity of this function? All right. Otherwise, yeah. So let's try. Let's recompile it. It will work. Int. Okay, it's long int. Right, long int. Let's try this. Still works. Fib. I'll do fib 50. 40. Still works. Okay. Please smile. Fib 50. Okay. I think we figured out like 85 or something. Where's the problem? No, like 90, right? 90. And a fib 92, right? Still works. Fib 93 is the problem. What? Sorry. Yeah, fib 93, fib 94. Yeah. Oh yeah, 94. 93rd number is the problem, child. Okay. Right. So we see that 93 is the biggest one. Okay. Now I can finally submit it. Added fib example. And we don't want this one here. Alright. Now, is anything else interesting from today's lecture? So for loops, right? Do while we don't really care about too much. I said I'm willing to change my mind. Alright. So do while looping. Yeah. For loop, right? Well, yeah, at least one, right? So yeah, so one thing we saw break's pretty clear. We also have continue. What's the idea of this continue?
To skip the
rest of it. Yeah, rest of it, and you go back to the beginning of the code, right? So you skip remaining statements, proceed to the next iteration. Again, some languages don't even have continue. Break is very nice. Break I use it quite a bit in pretty much all. Continue is less used because usually you can use you get by with else and things like that. It's just an extra construct, right? So we'll go into it, right? So we can continue, right? Yeah, a little famous printing of the half the what you call egg lead, yeah, pine tree, right? Into a pine tree. Right, and things like that. Yes, so what else? So do while loop. Right, that's all good. Yeah, so what do you, oh yeah, of course. How do you break out the loop if you don't have, if you have a forever loop? You can do Control C, right? Control C usually will do the trick, right? Yeah. Okay. Any questions on looping today? No. Okay. I think we can finish today. I don't think anything actually. 12:40. Actually, we have 10 minutes. We could do something else actually, or do you want to stop
on the quiz?
Oh yeah, you can work on the quiz by the way. Yeah. Oh, I need to fix this actually still. Okay. So the quiz also for the homework. Four people have submitted homework for the week 2, right? All right, very good. Very good. On day 4 quiz. All right.